is? Well, I'll skip over that slide then. A bit about me, the obligatory slides. I said I'm currently working now for Optum. I think the largest healthcare provider, well, software provider in the UK. I should really learn the new strapline. Okay, start off with the definition. This is from AI, so it may be right. So again, a supply chain. It's been existed for a very long period of time. How does this relate to software? This is more down to the sort of organizations, the persons, and where you can get all your components from. So essentially, supply chain, the problem boils down to one key thing, which is a bit tricky. Can anyone see the problem? I said the mandatory XCD comic. Again, it's a really good one, does explain most modern software engineering. And with supply chain, you need to know all your different sort of layers in your stack, and you kind of come into this interesting problem that, as this diagram points out, that who exactly is this guy in Nebraska who's been maintaining this software? He's producing all this code, you're taking its packages. Who is he? How do you know that this software that's been updated with the latest version is actually from that guy? Or is it just that guy's, that guy's claim account? Has that guy in Nebraska finally sold up? Flogged it to his project to somebody else to shove in a load of adware? Because that's never happened before. So it's an interesting problem. And again, with the internet and trust and identity, can anyone see the problem? So I'm going to go through some possible routes you can go through. The biggest one is, how do we start building trust? How do I start working out who you are? Does anyone remember, I'll get it right around, GPG, and what that was there to try and solve? Right, judging by the one person who put his hand up, right, who actually does code signing in GitHub? That's a couple more. What code signing does, especially if you should be using the GPG one, not the SSH one, is it essentially starts to trying to get trust into these code changes. Because the great thing about it is that you sign your commits, you can then use the infrastructure that PGP put in to say, okay, that's been signed by somebody, do I trust them? And this is where you get the whole web of trust, which nobody ever does. But it's all there if somebody actually wants to get involved with. And again, to configure it, the documentation on GitHub's really easy, really simple, and you just add it to your configuration. Again, this is the big problem you've got with trust is that there's no silver bullet, because if there was, somebody would have be selling it as a SaaS by now. So you're looking at all these different layers. So with this layer, you can now start sort of trying to map to say who's done what. And whether you can overcomplicate it, I'd also like to give a shout out to whatever the fine gentleman was that I really should remember his name at DevOps Days London conference, who shouted it out. I instantly forgot the product he actually told me, but hey, these things exist. But yeah, is it looking at how do we reduce the blast radius? So you've got your signature. That's on your machine. But again, it's like with any secret, any credential, it's on your machine, somebody's going to steal it. Might be your machine, the whole machine they steal, or with the current attacks with the different development tools where they just grab everything in your local environment. So by using things like subkeys, you can use a token vending machine to spit out these short-dated certificates that you can use signing to sort of get around this problem. So yes, it reduces the amount of time the certificate's been leaked out and about, but it's not, there's no real nice solution. It is overhead, but again, you're trying to put trust and identity onto the internet, which it's not exactly the best technology to try and do that with. You've got more options. Again, you can go all fancy with hardware. Again, doing stuff with the NHS. They love their hardware tokens. So you've got the, is it FIDO specification?
FIDO 2. No.
I will remember the correct terms, thank you. And again, you can get your nice OptumUK with all fancy Bluetooth, whatever, however much money you want to spend on it. If you're feeling cheaper, you can also put things like GitHub app on your thing. Then you've got sort of multiple forms of authentication. So you've got to have your phone, you've got to have your tokens, all those bits. All this to try and map down that, okay, are you the person who's linked to this token, whether it's hardware, software, are you the person who's actually doing these changes? Yeah, it's more layers, it's more faff, but it's kind of the only approach we've got at the moment, which is a bit of a disappointment. But it is what it is. Anyone know, well, I'm going to say, anyone working in regulated space will know attestation. And now the mountain of spreadsheets that you have to deal with to get through these processes. But, surely there's a better way. Since we're dealing, well, most of you would have seen, was it SHA-SUM files when you're downloading stuff to sort of check that what you've downloaded is actually what you've downloaded. One of the problems you have with that, especially early on, and especially if you're, what was it? Who's the monitoring? SolarWinds. Yeah, there's a small problem when you've got just a flat file with all your checksums in. That can be tampered with. So there's a whole bunch of technology now around signing, where you can essentially define, this is my attestation file, you can cryptographically sign it, you can attach that to any evidence, like your test plans, all those bits. So you can all cryptographically say, hey, this is what I've done with this particular release. The problem you have with a lot of this cryptographic stuff, and again, like with the diagram, does anyone see any of the small flaw with it? It's trust. At the back, do you wish to shout out? Yes, that's why I'm going to keep trying. So again, this is a nice offering that GitHub provides. The problem is that you're trusting GitHub, that their cert store and all the credentials and stuff isn't going to get compromised, isn't going to that. So the problem with a lot of this stuff is that who do you trust? Where do you start that trust? How do you start doing the verification? Which is an interesting problem. Again, there's loads of really nice tooling for it. This is very skewed towards GitHub at the moment, because guess what I get paid to do? You can basically get got a nice action as part of your build release, does it all, so you get your test plans, all the documentation, sign your application, shove it all in your attestation file, have it all signed, so you can say, hey, compliance officer, look at all this paperwork and stuff you don't need to do, because, hey, I can cryptographically prove all the way through the chain who's done what, all your documentation, all this points to that, and, I know if anyone's tampered with it, or any of those bits. There's also, again, showing how you can use the GitHub tooling just to say, hey, does this actually match any of its, attestation, documentation? Has it been tampered with, any of those sort of bits? And you can use the gating for that. Did I put? No, I didn't. You can use things like OPA or whatever it's been rebranded to say, hey, does this match all the documentation? Has it all got the correct accreditation test plan, all those bits? I use that as gating to say, like pushing onto things like Kubernetes or ECS clusters. So you can all bag tag and make sure none of this stuff leaks through. But yeah, it comes down to this little problem. Again, try to find some interesting quotes. Yeah, just because I can cryptographically prove that this is the test plan, this is the code, this is the build, all these bits, doesn't actually mean that it is. It just means I can cryptographically prove it. So the big problem you have with essentially supply chain is you can't really trust anybody, because fundamentally, again, was it Stuxnet? Was a massive shotgun blast by certain governments to take out, was it the... Yeah. Who got caught in that blast? So just because they won't come after you doesn't mean if they compromise any of the systems that you trust. Like, if they want to, if a government wants to infect particular dissidents, anything like that, go after GitHub, pop their trust. Do injecting there, and then you can mess around with any of those keys, any of those bits. And you've got the other problem with it, was it with the alleged North Koreans who are pimping out their engineers. Just because you employed a contractor doesn't mean that contractor's actually working for you. So yes, you can cryptographically prove that that contractor's done all these X, Y, and Z, but you can't kind of trust what they did because there's so many things happening out there. So yeah, you kind of have to end up in this posture of trust no one. It's not a particularly helpful point to be in, but yeah, it's just where we are, is with the difficulty around like bagging and tagging. It comes down to fundamentally is that where you're getting your source code from, you don't know. Yes, somebody can tell you. Yes, you can go to Microsoft and say, hey, we have all these signatures and stuff like that. It could be any intern out in India who's generated this stuff, who's had a bad day. That's what happened to SolarWinds. And yeah, it is probably a more difficult problem that's worth solving. So if you can't solve trust, if you can't say, I 100% support my supply chain, what can you do? It's all damage limitation. So we look at modern software engineering. So you've got your source code. There it all is, big pile of it. Like I say, how many people here can actually print out everything that's required to run their application? Because again, I think that's everything required to put a man on the moon. Try not to use XAZD all the time, but I found this one. Yeah, modern software engineering, to basically do print hello world, even in C, you're sat on top of this massive pile of code, of hardware. Most hardware these days has firmware, so that's software. So you have this massive pile. You are very much, stood on the shoulders of giants to produce this stuff. So this is when we come back to supply chain. What actually...
Just to add on that bit you just had there, anybody's seen, framework, the modular
laptop.
They've just shipped 200,000 machines with dodgy firmware.
Yeah.
So that's a key example would be just bypasses secure boot completely.
Yeah, and that's the problem. Even with the TPM, there's so many different ways.
If you don't have a secure boot TPM, you can't trust the boot.
Yeah.
Usually, and then if you don't have BitLocker on, you can't trust BitLocker then.
No, because it's all compromised.
Back the keys in.
Yeah. So all the way up. So this is the problem. So okay, again, this is another interesting quote. Laws like sausages cease to inspire respect in proportion to how you know they're made. It's like with your software. You're going to have to start looking. Okay, how was your sausage that you run all this on was made? So, how do we go about this? Luckily, again, as part of this talk, there is a solution. We got the concept of SBOM, a software bill of materials. As I said, I do apologize, but that's as sexy as I could make SBOMs. I tried really hard, and AI just came up with nothing. So, what is SBOM? Bill of materials, so you can start going through and say, okay, what actually makes my software? Okay, there's everything that I've written, that is all the libraries that I know I've included, and then you start going through the stack. Big problem with it is there isn't one standard. God bless them. There's in Toto, which does the high-level stuff, but the actual specifications for doing SBOMs, there's a whole bunch of different vendors that support it. They'll sell you stuff. Unfortunately, some of them are in XML, some of them are not, so pick your poison. And this gives you basically a framework to then start, okay, how do I start listing what's in my software? Two examples, you've got SPDX. Anyone using GitHub, if you go to It's the data thing. Insights, down the bottom dependency, there's an export SBOM. That'll spit it out in a version of SPDX. For most of the Azure guys, if you're doing .NET, there's some really good tooling around Cyclone DX. I'm pretty sure that Cyclone DX came from the .NET camp because there's lots of really good plugins and stuff like NuGet. And it also outputs in XML and other sort of micro-isms. But yeah, they do have two different philosophies. The SPX is very much geared around license compliance, like listing the software, whereas the Cyclone does seem to go in a lot more detail about the nuts and bolts. So it's looking at what do you want, like who's your audience for your SBOM. Ideally, there would just be one standard, which would have all this built in, but we're not quite there yet. We'll see how many more iterations there are. Yeah, they're both open source, they're both quite good collaboration, they have all, yeah, they're all nice open standards. I'm not too sure if they're in the cloud, or was it initiatives or not, but in toto is, so there'll be some links. So yeah, pick your poison, decide what you want to try and solve. Here's an example. Again, I just went to GitHub and tried to find something looking reasonably interesting. Turned out to be quite surprisingly difficult because a lot of people aren't filling out their proper documentation. So this is the Backstage SBOM. There's an example of where it sort of pulls out. So the nice thing about SBOM is that, say if you've got your application that's, hypothetically written in Node.js for some strange reason I'm talking about. Your package manager, your yarn, whatever your lock file is, that'll give all your node dependencies. But if any of those dependencies are pulling in things like C libraries, that's not going to be in your npm lock file. This is where things like SBOM you can start taking from multiple sources. So in here, I was trying to find one with a decent licensing and stuff like that, but there's a whole bunch of extra fields that you can have per package to say, what's the license? So you can basically say, this is my complete stack, for compliance, you can look at your complete stack of your software set and say, hey, does anybody using any AGPL stuff? Does anybody know what happens when you find AGPL stuff in your build? Yes. Some people, your legal team gets very upset with you because essentially all your software is now open source, and you have to provide it to anybody who pays for your service or asks for it. Because again, these are part of the license bombs that open source communities have put in. So this is why, one of the SBOMs is very focused around compliance. So you can go through and say, right, what's the licensing? Because also the other thing is that you've got delightful third parties get open source packages that get militant, who may just change their license on a patch. So you pull in a patch update and just find that everything's now in breach of copyright law.
Didn't Redis do that recently?
Yeah.
Is that what you're on about?
And there's been some JavaScript ones as well. JavaScript ones are the ones that get particularly militant. So this is why, because it may be a dependency of an open source tool that you're using, like several deep, you may not even know about it. You will just update, pull it in, and boom. This is why SBOM's kind of a little bit more important than it's probably been given credence to. Because again, it just gives you this insight, and you can sort of track it and all those bits, and it keeps all your compliance a lot happier. And also, from an engineering point of view, you can start saying, right, who's using what bits of software? Are certain bits of software that we're using heavily used by everybody? Maybe it's an idea to start, paying for support if that's an option, because it is that reliant to your technology. Yeah, because the reason why you want to know the full stack was, if anyone remembers Log4j, what caught a lot of people out was that, I'm not using Log4j in my WAR. Great. What about the Java application server you're running that you haven't patched ever? So this is where SBOM starts saying, okay, your code, fair enough, but what about what you run it on? So in the case of, say, like Java, you've got your Java Enterprise servers. Okay, what are all the components of that? What are the components all the way down to, your infrastructure. And it's having all that sort of collected together to say what's going on. Yeah, what's going on? How was the sausage made? It's a nice example. It's built into npm. You can SBOM, spits out a whole bunch of formats. That Cyclone, again, I mentioned, they have a Node.js version. It actually seems to be quite all singing, all dancing. It does a whole bunch of things. So you can use that to pull out basically a whole bunch of various technologies. Also the security, vulnerability disclosure bits. Again, all this tech is there to try and help you say, okay, what's in your software? How was the sausage made? Is there anything you need to watch out for? Again, there's ChainGuard example. There are other vendors of containers, but I just thought I'd better give ChainGuard a mention. You can pull down their I will get better at saying words. Attestation, and because on all their containers they provide, here's our SBOM, here's all the different components, here's any testing, all that sort of stuff. You can pull it all out of that and say, okay, I am building my Node app. I'm going to use the ChainGuard Scratch because everyone's using Scratch containers, right? We can pull that together, smash it all together. Here's a full SBOM. I know how how this Node app works that's running on container, that's running on kube somewhere. And with the microservices, you can take that further. There's a whole bunch of tools, like there's a SPX merge. So you can say, okay, I have an application. I don't know, could be a pet store for some strange reason. You can have all your different components and say, right, this is my microservice. They generate their SBOM. Take all your microservices, smash them all together. Right, I, as the product owner of this pet store microservice shop thing, I now know how the sausage was made. I know all the different components. I know the different licensing and all those bits. So it's very much sort of builds together, give a good picture about what's going on with the full stack. And with this full picture, you can, as I said, do your security scans. Instead of you having to basically crawl all over different code bases, especially for things like compliance and other bits you can have as part of the your tool chain to push all this stuff up. And going back to the whole trust thing, is just because you don't trust anybody else, it doesn't mean that you can't then do your attestation on your components, on your SBOMs. Start pulling together all your documentation, because if you're working in a regulated space and you can point to say, hey, this is our SBOM, this is all the components, this is everything, it's all signed, we know it hasn't been tampered with, I know this cryptographically signed bit of software with all these dependencies that have been deployed on this particular cluster at this particular time. And it gives them all warm fuzzy feeling, and you want to make sure your compliance guys have the warm fuzzy feelings. So yeah, so you can take the tools we had for building up trust and then apply it to your stuff and to give you a good idea about what's actually going on. And then you've got the last line of defense, which is basically just buying yourself time. A lot of these sort of vulnerabilities will pop out. There is a flaw, don't worry, I'll get to it, that they'll pop out, somebody's compromised a package, somebody's done something silly. So usually, they pick this stuff up pretty quick. Open source community, there's lots of eyes, it's not perfect, but if you delay, you can sometimes sidestep a lot of these issues. Like with the worm stuff that's doing the rounds, if you held off picking up any of the latest updated packages, you just bypassed it all. So yeah, it's trying to work out ways like how can you buy time, to spot, to and to react. Strangely, a nice new feature from Dependabot from GitHub popped out in the summer. I wonder what they were told. It's around this whole concept of cooldown. So instead of saying, okay, a new package just popped out, I'll update it, pass it through, you can basically say, okay, I want to wait a couple of days. If it's a major change, maybe wait a week. And like I said, is that no one ever install a Apple 0.0 release. Wait for a 0.1. So you can then essentially delay your automation tooling around this. Again, it's a nice feature, it's relatively new, works with most software and package management tools, so this can then use to buy some time. There are some little quirks with it about when it's working with NPM, just the way that NPM works, because it's a beautiful package management tool. Yeah, I'll go through them a bit later. You've also got Renovate. Again, if you've got the choice between Dependabot and Renovate, pick Renovate. It's got more features. It's generally better. They've got the concept of minimal release age. So again, you can use this tune to say, okay, which are your high-risk projects, which aren't, which packages are pretty stable, boring. You can put on slightly lower cool-off periods. But as the point I was saying with the negative is that you're going to be waiting. So if there's a 0-day fix, you're going to have an escape hatch to try and punch through this to push it out quicker. But it's kind of the trade-off is, if somebody does put something malicious in, you want to stop it from spreading. But if you've got a 0-day, you kind of need to get it out the door. This is why you need to have a chat with your security team, decide which way they want to do the risk. Do they want to fail open or fail close? Did I not put that in? Probably not. If you want to spend some money, there are various tools like Nexus and Artifactory. The real value for them is that they have dedicated security teams who can do all the scanning. So you essentially use it as a filtering tool for all your public repositories to basically say, okay, what's coming through? They can scan it. If there's any 0 days, they can block stuff. So essentially, they're not the cheapest tools, so your mileage will vary. So depending on the size of your organization, again, as I work for Optum, which is now huge, so having this sort of tool makes a lot of sense to them, because then they can define the policy engines to say, how long do we want to do cool-off periods for different bits of software? What do we trust? What do we don't trust? And do this gating. So the engineering teams just point to Artifactory in our case, pull down these dependencies. They don't have to worry about it. It's all hidden transparently. And the security team can get reports and other things like that. If you're a small one-man band, you don't need this. Just having the security in place, just having sort of the delays, just say maybe don't grab the latest packages is probably good enough for you. Summary time. So yeah, basically the output from the discussion we had in the open sessions in DevOps days is doomed, but there's a whole bunch of different things you can try to sort of mitigate, the amount of impacts that you have on your supply chain. A lot of this around is just adding layers to try and, complicate, ways that people can basically tamper with your source code, how many layers they have to punch through to say try and impersonate you. If they do impersonate you, push out, code with malware in, how quickly does it get picked up by the rest of the community? When does it get spots? How quickly you can sort of roll back and remove those changes. Yeah, because a nice new feature in GitHub, missed the blog on it. Does anyone remember when somebody hacked one of the GitHub Actions and just pointed all the tags to the one with the malware in it? There's now settings in there to say, you've got to use pinned. So there's different tools. Yes, having pinned, you lose the readability, but it gives you a bit more security because it's a bit more fixed and it's harder to spoof. So that's basically all you can really do with supply chain. Oh, and yeah, please make sure you enable MFA. Yeah, so that's essentially the current state, as I have managed to find about sort of supply chain, all the different sort of tools out there. Any questions?